Welcome to today's tutorial. So in this tutorial, we are going to discuss how we can represent given sets into set builder notation. So this is a very simple question. So if you have not yet subscribed to the channel, make sure that you click on the subscription button and don't forget to click the notification button so that you don't miss out the videos that I'll be posting. And if you have any questions or you'd like to join any of my online lessons, it can be physics, biology, mathematics, or chemistry, feel free to contact me using these lines on the screen. Alright, so let's quickly begin to solve the questions. So we have a number of questions. Let me start with this one. Alright, so this question says describe each of the following in set builder notation. So this is a very simple question, like I said. So the first question that we have here is set A is equal to, and then we have 1, we have 4, we have 9, we have 16, and 25. So when you look at these numbers, these are perfect squares. Yeah, so to write this in set builder notation, you can simply just say, okay, in other words, let me just explain what perfect squares are. In other words, it's easier for you to find the square root of 1. It's easier for you to find the square root of 4. It's easier for you to find the square root of 9, 16, and 25. So these are perfect squares which are less than 30 or 26. You can write it in that way because when you're using set builder notation, you can either describe a set mathematically or using words. You can either describe a set using mathematical symbols or words inside the brackets. Alright, so in this case, I can use mathematical symbols to describe these this set. So so this one here said these are perfect squares, meaning we can write them as we can write this mathematically as x squared is such that x is a member of what? X is a member of natural numbers, and this x should be less or equal to 5. So if I write it like this, this means that if I get any natural number which is less than 5, so natural numbers are counting numbers starting from 1. So when we say 1, 2, 3, 4, 5, because we're saying less or equal to, meaning 5 is also supposed to be included into the in the solution set. All right, so this is exactly what you do. So if you get these natural numbers, you square them, you are going to get this set. For instance, if you square 1, you get 1. If you square 2, you get 4. If you square 3, you get 9. If you square 4, you get 16. If you square 25, if you square 5, you get 25. So this is the solution for the first part. All right, so the second part is also simple. Set B is -7, -5, -3, -1. So when you look at these are negative numbers, and then apart from them being negative, they are also odd numbers, because an odd number is a number that if you divide it by 2, it will always leave a remainder 1. Yeah, so these are odd numbers. So if you want, you can just write this in word form. You say x is such that x is a negative odd number less yeah, so let me not use less than, let me say greater than. So this is a negative odd number greater than -9 or -8. So you can write it however you think it's okay. If you want, you can use -9 or -8. It's still going to be fine. So you can say x is such that x is a negative odd number greater than -9. Okay, so let's move on to C. So C is also very simple. So set C can also be written in set builder notation as 2x, because when you look at these numbers, we have 2, 4, 6, 8, 10, 12, 16. There is no 14 there. So look at that properly and check. There is no 14. So since we don't have 14, so we can easily just say 2 times x is such that x is a member of natural numbers, but this x should be less than 9. And in this x, we have to exclude what? 7. So we can say excluding 7. Or if you don't want to say excluding 7, you can simply just say x is not equal to 7. Where x is not equal to 7. So x can be any number that is less than, any natural number that is less than 9, but we are excluding 7 from the solution set. So when you replace any number that is less than 9, excluding 7, in this expression here, you get this set that you have, which is set C. Alright, so let's quickly move on to set D. So when you look at set D is found by adding numbers consecutively. So if you say 1 plus 1, you are getting 2. 2 plus 2, you are getting 3. 3 plus 3, you are getting, 2 plus 2, you are getting 4. 3 plus 3, you are getting 6. I don't know what I'm doing. Sorry. Supposed to be 1 plus 1, 2, 2 plus 2, 4. And then 4 plus 4, 8. I don't know how I brought in 3. And then 8 plus 8, 16. 16 plus 16, you get 32. So how do you find the formula that is going to suit that? So you can use geometric progressions. If you did geometric progressions high school, this is a very simple question, because we can see that this is a sequence here. So if it's a sequence, we have to identify whether it's a GP or an AP. So when you look at this, when you find the value of R is found by getting the second term over the first term. So the second term there is 2 over 1. So this is giving us 2. Let's try it also for other numbers. Let's get 8 and 4. So let's see if this is a GP. So if it's a GP, if we get the answer 2 again, we conclude that it's a GP. So if it fails, then we try to find the common difference. So this is a common ratio that we're finding. So let's try to find the other part. We get 8 and then we divide it by 4. We're also getting 2, because you get the number that is there divided by this. Firstly, I got 2, I divided by 1. I also got 8, I also divided by 4 to get this 2. So since we have gotten 2 on both cases, we conclude that this is a GP. So for GPs, we know that the nth term of a GP is found by A, which is the first term, the common ratio, then n minus 1. So let us find the nth term. That is what we are going to get as the value, as the function that we put there. So the value of A, which is the first term, is 1. And R is the common ratio, which is 2 in this case. Then N is the nth, N is the one that we're going to call X. So X minus 1. So the formula will therefore be 2x minus 1. So this is what we are going to put here. 2, then x minus 1. So the same way I found this, you can also use it to find this 2x here on part C. So 2 to the power x, x minus 1 is such that x is a member of what? Natural numbers. But these natural numbers are supposed to be less than what? 7. So we say x should be less than 7. So if you put any natural number that is less than 7 in this expression here, the resulting set will be set D. You can try it out. Alright, so thank you very much for watching today's tutorial. See you in the next tutorial video. Don't forget to click on the subscription button and the notification button so that you don't miss out the videos that I'll be posting. And then in case you have any questions, feel free to contact me using any of these lines on the screen. My name is Harmtedy. See you in the next tutorial video. Shalom, shalom.